This is going to be the rigid motion for a translation. Rigid motions are movements of a figure that keep the figure with the same measures of angles, measures of distance, line stays lines, and between stays between. Rigid motion preserves A, B, C, D. Rigid motion is also called an isometry in our book. I am going to have a composition of two reflections for my rigid motion called a translation. The reason it's going to end up being a slide or a translation is because the line L is parallel to the line M. The slide I'm going to end up with, the translation I'm going to end up with, is going to be twice the distance between the parallel lines. So if I measure the distance between these parallel lines, the perpendicular distance, it's 2 centimeters. So in the end, this shape is going to slide 4 centimeters. It's going to slide in the direction perpendicular to those parallel lines. So it's sliding this way. It's going to slide the way I do my composition. You do these compositions just like you do in algebra. You work them inside out. I reflect over L, take that new image or output and reflect it over M for my final product. Now I'm going to do this as reflections. So I'm going to put my compass at F. I'm reflecting over L so I don't worry about M being there. Do my normal reflection thing. I didn't make it long enough. That becomes, I'm going to use my pencil because it's not the final product. This becomes my F prime. I'm going to do, with my compass, L. Find the two places it hits my reflecting line. There's my L. L prime. I'm going to use the ruler for the other two because some of you like the ruler better. I just have to make sure that my line is perpendicular to my reflecting line. This measurement is 12.7. That's where my A prime is. Do the same thing as G. Line it up nice and perpendicular. Measure G, looks to be exactly 1. Measure G, it's going to be exactly 1. There's my G prime. I then am going to reconnect these to get my first image, my first output. I missed kind of G on that one. Draw that better. Okay, now I have to reflect it over M. And I'm going to use the ruler on that one too. This is really close. It's about 2, here, I'll do it in red. It's about 2 centimeters here, so it should be about right there. This one is about 3 centimeters, so it's about right there. And now I'm eyeballing these distances also. I'm going to use the compass on these two. Forget about my stuff from L. This becomes my reflection of G prime, or G double prime. Same thing from A. Forget about L being there. A is going to be A double prime is going to be right there. I'm going to line up the shape. And again, my marker's kind of fat. And that's my final image. I'm supposed to call it POST, F matches up with P, L matches up with O, S matches up with A, and T matches up with G. Now, if you look at the blue and the red, it does look like I slid my shape. I'm going to trace this here. This is my original flag. I want you to notice that it's a slide to here. It's a slide back and forth. Now, that slide that I'm doing is a vector. The slide that I'm doing is 4 centimeters long, you can tell that, and it's in the direction perpendicular to the parallel lines. It is, again, 4 centimeters long, 15 to 19. I can do 15 to 19 again, perpendicular. In other words, the vector of my slide is 4 centimeters long, perpendicular to the parallel lines. So 14 to 19 long, in the direction of L towards M. In the direction of L towards M. This is my vector V of my translation. Vector V is 4 centimeters long because it's twice the distance between the lines, and for now it's in the direction down and right. We'll learn how to get a perfect angle on that direction later. Now, we're doing down and right because in Algebra 1 you had parent graphs and you translated them vertically up and down, and you translated them horizontally left and right. And if I put the down with the right, that is the same as sliding along my vectors. That's because down and to the right gives you a vector that's a hypotenuse of a right triangle. And my vertical and my horizontal are the legs, and my vector is the hypotenuse. So the vector's magnitude is my vertical translation squared plus my horizontal translation squared, and I take the square root of it. That's how I got the 4. I also got the 4 because I knew the parallel lines, doubled the size of the distance between the parallel lines, gives me the magnitude of my vector. Vectors always have both magnitude and direction.